Hello students, welcome back to another session. It is on refrigerants. We are going to see refrigerants desirable properties, refrigerants classification and refrigerants nomenclature. So these are the three topics in short we are going to discuss here. So far in this unit we have seen all these topics: introduction to refrigeration, unit of refrigeration, COP, ideal cycles, and we have solved numerical problems also on ideal cycles. Now we shall see the different types of refrigerants, classification, properties, nomenclature. So here refrigerants, what is actually a refrigerant? It is a refrigerant is working substance used in refrigeration and air conditioning systems to absorb and release heat by undergoing phase changes between liquid and gas. So this is the actual refrigerant definition. It is a working substance used in refrigeration and air conditioning systems to absorb and release the heat by undergoing phase changes between liquid and gas. Between these two, the changes are responsible. The changes are happening for which this refrigerant is responsible, students. So role of refrigerants in refrigeration cycle. The refrigeration cycle consists of following steps: compression, condensation, expansion, and evaporation. Already we have seen these processes. The compression is the refrigerant gas is compressed. So normally a refrigerant is in the form of gas is compressed, increasing pressure and temperature. The condensation, the high pressure gas is cooled to the in the condenser, turning into liquid. So that is the gas. The high pressure gas is cooled in the condenser and that will turn into a liquid. And in expansion process, the liquid refrigerant expands through an expansion valve, lowering pressure and temperature. So both it lowers the expansion process. It is normally expansion valve through which the pressure and temperature is lowered, and evaporation process, the low pressure liquid absorbs heat in the evaporator, converting it back into gas. So that is evaporation process. This continuous cycle allows heat absorption from a low temperature space and rejection to a high temperature environment, resulting in cooling. So that is the refrigeration process actually. So here what is happening, the low heat allows it is the continuous cycle that allows the heat absorption from low temperature space, that is low temperature area, and rejection to high temperature environment. Normally when we see the refrigerator, inside the refrigerator it is a low temperature area or space from which the heat is absorbed and released to high temperature environment, that is a outside refrigerator. So next topic is desirable properties of refrigerants. Here, these are all the desirable properties. An ideal refrigerant should possess the following thermodynamic, physical, chemical, and economic properties. So now we see thermodynamic properties. It should be low boiling point. So here ensures rapid vaporization and better cooling. High latent heat of vaporization. It increases cooling efficiency. Low condensing pressure, it reduces the compressor work, and a high critical temperature, it enhances efficiency at a high ambient temperatures. Low specific heat of liquid, it improves the heat transfer. So low specific heat always improves the heat transfer. These are the thermodynamic properties, thermodynamic desirable properties. Normally, to achieve this, in our real refrigerants is really a difficult task. In physical properties, low density in vapor form, it reduces compressor size. When we have low density in vapor form, then the compressor size is in compact. We can have low viscosity, ensures smooth flow and minimal pressure drop. High thermal conductivity facilitates better heat exchange. Non-flammable and chemically stable, it improves safety. So in safety norms, it should be non-flammable and chemically stable. So these are the physical properties, and we have chemical and economic properties as well. We will discuss them. Chemical properties, it should be non-toxic, safe for human exposure, non-corrosive, it protects refrigeration system components, chemically stable, prevents decomposition, environmental friendly, should have zero ODP, that is ozone depletion potential, and low GWP, it is global warming potential. So this is it should be ODP as well as it should be low GWP, global warming potential. So these are the chemical desirable properties. And the economic properties, easily available and affordable, low maintenance cost and minimal leakage loss, safe to handle and transport. Classification of refrigerants based on chemical composition. So hollow carbon refrigerants, that also known as fluorocarbon refrigerants, and these are CFCs, chlorofluorocarbons, that is R12, banned due to high ODPs. So that is the drawback. High ODP, it is normally non-desirable, and it is banned. R12 is banned nowadays. And HCFC, that is hydrochlorofluorocarbons, it is R22, phased out due to moderate ODP. So here it also produces moderate ODP. That's why we have it is also not much used. HFCs, hydrofluorocarbons, that is R134A. So it is having zero ODP but high GWP. So that is the drawback here. It produces high GWP. It should be as minimum as possible GWP. Inorganic refrigerants, ammonia R717, used in industrial refrigeration. It is very popular in industrial refrigeration systems. Carbon dioxide R744, it is used in commercial refrigeration. In commercial refrigerations, it is used carbon dioxide. And hydrocarbon refrigerants also popular HCs, that is HC, R290 propane, R600A isobutane. These are natural alternatives with low GWP. So that is the advantage. When it is low GWP, it is desirable characteristic. Based on the operating temperature, high temperature refrigerants greater than 0 degrees Celsius, that is R134A, R600A, these are other refrigerants. So here this R134A, it is HFC, it is not much used, but R600A is used in most of the places. Medium temperature refrigerants, so that is minus 15 degree Celsius to 0 degree Celsius, that is R22, R404A. So R22 is not much used because it is having moderate ODPs. Low temperature refrigerants lesser than minus 15 degrees Celsius, it is R502, R744. So R744 is carbon dioxide. It is normally used in commercial refrigeration. So this is the classification. So designation and nomenclature of refrigerants. So designation or nomenclature is another important aspect in refrigerants. We have to consider this in while selecting the refrigerants. The ASHRAE is American Society of Heating, Refrigerating and Air Conditioning Engineers. So this ASHRAE, they have the research and development centers. They are doing all the research in the air conditioning and refrigeration systems. They are producing the handbooks on every year. You can download those from ASHRAE website, and also that handbook is one of the references in our reference books that you can refer also. This gives very useful information on HVAC. So ASHRAE numbering system, refrigerants are denoted as RXYZ, where X is carbon atoms minus 1, Y is hydrogen atom plus 1, Z is fluorine atoms. So these are the three terms with R used. So X is carbon atoms minus 1, and Y is hydrogen atoms plus 1, and Z is fluorine atoms. So this is the one of the ASHRAE designation. And for example, you can see here R12, that is CCl2F2, two carbon atoms, no hydrogen, two fluorine atoms. So this is the designation R12. R134A, it is C2H2F4. So three fluorine atoms, two hydrogen atoms, Special nomenclature R400 series refrigerant blends, that is R407C. It is blended refrigerants. R500 series, so azeotropic mixtures, that is R502. R600 series, it is hydrocarbon refrigerants. R600A is isobutane. So with this also, this is represented in R600 series. R700 series, inorganic refrigerants, that is R717 for ammonia, R744 for CO2. So these are the designations given as per the special nomenclature method. So properties of common refrigerants, students, I have made a table. So this will give you the fair idea on this. R12, the chemical formula is CCl2F2. It is the boiling point is minus 29.8 degrees Celsius, and ODP is 1, GWP is at very high, that is 10,900. So world domestic refrigeration, it is almost banned. And R22 CHClF2, it is my boiling point is minus 40.8 degrees Celsius, and ODP is 0.05, and GWP is 1.810. It is used in AC and refrigeration. Now it is ruled out. Now nobody is using it. R134A C2H2F4, it is the chemical formula. Boiling point is minus 26.3 degrees Celsius, and ODP is 0. So that is the very good advantage. But GWP is little higher, 1430, and it is used in car AC domestic refrigerators. And R717 ammonia, it is NH3. This is minus 33.3 degrees Celsius, and ODP is 0 and GWP is 0. It is widely used in industrial refrigeration. And R290 propane, it is C3H8 minus 42.1, and if you see the ODP is 0 and GWP is lower, it is used as natural alternative for ACs, air conditioning systems. And R744, it is CO2, carbon dioxide, and minus 78.5 boiling point, and ODP is 0 and GWP is 1, and it is used in supermarket refrigeration. So where it is displayed with a open system, so in that particular refrigeration system, it is used. It is a open type. It is not a closed, and there is no door and all, and there will be a area where refrigeration is taking place. So in that, the carbon dioxide is used as refrigerant. Environmental impact of refrigerants. Here, the ozone depletion potential, that is ODP, CFCs and HCFC has high ODP, damaging the ozone layer. So ozone depletion potential should be as low, or it should be zero. HFCs and natural refrigerants have zero ODP. So zero ODP is always advisable to use. Global warming potential, that is GWP. HFCs have high GWP, that is R134A GWP of 1430, and this is little higher, and it should be minimum. It should be minimum as well. Natural refrigerants like CO2 and ammonia have low GWP, such as 3 and 1. International regulations. So Montreal Protocol, it is 1987, banned CFCs and HCFCs, whereas Kyoto Protocol that came in 1997, it has the regulations on HFCs, and F-gas regulation, that is EU, that is European Union, 2014. They have stringent norms on refrigerants and restricted high GWP refrigerants. They have restricted, and they have made a lot of changes in refrigerants. Alternative and future refrigerants. Natural refrigerants, that is R717 ammonia, R744 CO2, R600A isobutane. We have hydrofluorofluorofilins, HFOs. This is R1234YF, low GWP, replacing R134A. So HFOs are becoming popular nowadays. Blended refrigerants. These are the blended refrigerants, R407C, R410A, combining benefits of multiple refrigerants. Solid state cooling, magnetocaloric and thermoelectric cooling as future alternatives. So these are also another type of alternative methods coming up nowadays. And solid state cooling is not that appealing one, and maybe in near future a lot of developments may take place in solid state cooling also. So these are the refrigerants. All three topics we have seen in a very short and crisp manner. Definitely you could have understood, students. So this is the end of unit number 1. In the next class, in next session, we are going to start unit 2. In unit 2, vapor compression refrigeration cycles, and it is a popular cycle in refrigeration systems that we are going to discuss in detail in next unit as well as in next session. Coming to books, these are the books as usual, reference books. Rajput is a very good book, and you can also refer Aurora. And I suggest you to refer Kurmi book. These are the references, Kurmi, and these are the NPTEL and brighthub-engineering.com. So this also you can refer for additional information, students. Here we are completing this unit. In next session, we are going to see unit number 2. Students, I suggest you to practice more number of problems, and in earlier sessions we have discussed the derivations, a few equations. All those you have to remember, otherwise you will struggle to solve problems in exam, students. So please remember those uh, equations and values, and values also, few values you have to remember. I have mentioned then and there. Please make a note of those values and keep in mind. Those will be very handy in solving the problems. Thank you, students. We will meet again in next session, where we are going to start unit number 2. Thank you.